Good morning. Today's task is known to you. Today we are going to do number of questions. Isn't it? We are starting. We have done enough articles so that we can do some questions. Of course, after that I will be taking few more articles which are there. They are momental ellipsoid and equimomental bodies, so that we will do later. So first of all, the articles which we have done already, let us use them. How to use them? Let us do some number of questions based on it. So the very first question which I am taking is to find the moment of inertia of the area bounded by r square is equal to a square cos 2 theta about its axis. I don't know whether you are familiar or not this curve. My request, please go through any arbitrary book of differential calculus. You will find some well-known curves there. So please go through them and try to remember, because we will be using them time to time. So here I am using the equation of lemniscate. So this is lemniscate given by r square is equal to a square cos 2 theta. When you draw this lemniscate, it will be in the form of two loops, and they are in between minus pi by 4 to plus pi by 4. The two loops, they are in between minus pi by 4 to plus pi by 4. I think the figure is clear to all of you. And this is a well-known curve. So it is lemniscate. Its complete name is lemniscate of Bernoulli, but lemniscate is sufficient. Now, let us consider, as we did in all the questions, consider an elementary mass. Now, you can observe that this is an area. That means it is a question of two dimension. So, what we have to do? It will be a type of lamina on the plane of the blackboard. So, we have to consider the elementary mass at a point P. Now, what will be this mass? Length into breadth, r d theta into dr. So, it will be r d theta dr, and its mass will be this area multiplied by the density. And of course, the mass, whole mass, will be its integral, and this will give you the mass of this particular portion. So it is, whole mass is 4 times. This is symmetrical to this. So this is 1 time, this is 2 times, this is 3 times, this is 4 times. So the total mass will come out as 4 rho integral between 0 to pi by 4 and then 0 to a under root cos 2 theta. Why? Because r square is given as a square cos 2 theta. So it will be the value of r, we will substitute here. So it will be a under root cos 2 theta and then r d theta dr. A very simple integral. What you have to do? First, you integrate with respect to r and then put the values, and then with respect to theta. Why? Because it is a function of theta. R is a function of theta. So you have to integrate it first. So it will come out like this. So you will get 0 to pi by 4 cos 2 theta d theta, and put do theta is equal to t. So you will get 2 d theta is equal to dt, and the limit will also change. It is from 0 to pi by 2. So you can get rho a square 0 to pi by 2 cos t dt. Okay, so that will give you the value of the density in terms of mass of the lemniscate. I hope it will be clear to all of you. So we found the density as capital M divided by A square. What is capital M? Capital M is the mass of the lemniscate. What is A? A is this length from here to here. This is A. Okay. So one thing is clear to you. First you find the mass. Now next you have to find the moment of inertia. So the moment of inertia, you know, it will be 4 times rho r d theta dr. This is for mass, and then perpendicular distance square. Now what is the perpendicular distance? PL, and PL is r sin theta. So it's a square. Perpendicular distance is square. Now the same thing we will do here also. It is again a double integral from 0 to pi by 4 and 0 to a under root cos 2 theta. So first of all you will integrate for r. You can observe here r is square. So r cube, its integral will be r4 by 4, and then you will put the values, you will get this much. After that you have to integrate 0 to pi by 4. Now there can be number of ways, whatever you like you can use. So it will be put 2 theta as t, you will get cos square t, 1 minus cos t dt. So when you solve this integral, you will get the result ma square by 16 pi minus 8 by 3. Now if you have any problem in solving the integral, you can comment. I will solve on the next time. Okay, but I know you are in this may be the course of BSc final, so till now you know very well how to solve this type of integrals. You can use the gamma function easily. So that's all for this question. Now let me take one more question, a very simple question. Find the moment of inertia not moment of inertia. This question I am taking for product of inertia. Find the product of inertia. Now recall the product of inertia in 2 dimensions. It is summation mxy. So first of all I will write the question and then solve it. Find the product of inertia. I have chosen some important questions which will give you standard methods to solve the questions. Product of inertia of a semicircular wire about diameter and tangent. At its extremity. So in this question what we have to do? We have to find the product of inertia of a semicircular wire. So this will be the figure. This is a semicircular wire. and about which axis? About OX and OY, at its tangent is at its extremity and diameter is your one axis. So you know what you have to do? You will consider a elementary portion, that will be A d theta. If this is d theta, A is the radius, so elementary mass present at P, of course, elementary mass at P, it will be A d theta. So the whole mass will be integral of A d theta into rho, and theta varies from, you can consider here, you can consider here, so theta varies from 0 to pi. So it will be rho A pi, isn't it? Rho A pi. So that will give you the value of density m divided by A pi. M divided by A pi is the density of this circular wire, semicircular wire. Okay. Now the next, we have to find the product of inertia. What it will be? Product of inertia, you know, it is summation mxy. So summation mxy means integral of rho A d theta and then x coordinate and y coordinate of this P. So what is that? This is like this. If it is L, so it will be OL and PL. And the integral varies from 0 to pi. Now next step, all of you know, we have to put the values of OL and PL. So it will come out as 0 to pi. Now rho can be substituted as m divided by A pi, and then A d theta, and then what is OL? OL is, this whole is A and this is A sin theta. So it will be A minus A sin theta, isn't it? This whole is a radius, and from this triangle you can calculate, this is theta. So you can calculate, actually P will be somewhere here. They are very close to each other. So you are considering this triangle. So this length will be base. So it will not be sin theta, it will be cos theta. This will be the base. So it will be A cos theta. Now this is A sin theta. So multiplied by A sin theta. I hope this thing is clear to all of you. We found the value of OL and PL. P is taken over here. PQ is the small portion. So this angle is theta. So this whole side is A, that is the radius. Out of radius you have to subtract this quantity, and this quantity is A cos theta, because this is also A. So this is A minus A cos theta. and then a sin theta and then a d theta. Now again, a very simple integral. All of you can solve it, and after solution you will get 2 ma square by pi. Split it into two parts and then integrate. You will get the result 2 ma square by pi. I hope there is no difficulty in solving this question. The integration is very simple, and you have done so many times this kind of integration. So today we have taken 2 questions. Now next time again I will try to cover 2 more questions, or if it is lengthy one, only 1 question, whatever it may be the case. So that's all for today. Thank you very much.